Have you ever wondered what is on the other side of this framework that we use every day? How does your JavaScript code get converted into a full native application? Well, that's what we'll discuss today. Hello, I am the Ordinary Dev and this is React Native Under the Hood. Running a React Native application is a very complex process. Let's break it down into 3 sections. I am calling this first step preparation because in this stage, 2 important things are prepared separately which are used later during the main execution. The first one is the JavaScript bundle. All of your JavaScript files, including the node modules, are bundled into a single JavaScript module by Metro. It then serves your bundle over the network and is finally loaded onto the target device. This bundle is fully optimized and is ready for execution. Now, on the target device, the native apps are initialized. To give more context, our goal is to run the JavaScript code that we just bundled onto the native target platform. So, we need to first initialize the native apps. On Android, the entry point is main-activity.java and appdelegate.mm on iOS. This step creates a native execution thread which will be required as we move on ahead. Now that we have our JavaScript bundle and the native thread setup, we are ready to move on to the next section of this video. Take a look at this diagram. This is a higher level representation of what happens under the hood of React Native. But before we go through each step in detail, I want to highlight these 3 threads that are used in this process. JavaScript thread, native or the UI thread, and finally the shadow thread. For context, a thread is a single flow of execution in a process. So, the JavaScript thread is responsible for executing JavaScript, native thread executes native code and renders UI, and the shadow thread executes C++ code, which we'll get into later. Now we all know that JavaScript needs a runtime to execute. The JavaScript runtime consists of many things, one of which is the JavaScript engine. React Native used to have JavaScript Core or JSC, which is a popular JavaScript engine, but in the newer version it uses Hermes, which is an engine designed to improve the performance of React Native. With the addition of a runtime, the bundled JavaScript starts its execution on the JavaScript thread. Keep in mind that the goal is to run the application natively. But how? We need a way to communicate from the JavaScript thread to the native thread. In the old architecture, React Native used a bridge to allow the JavaScript thread to send asynchronous serialized messages to the native side. These messages had to be serialized in JSON format and sent via bridge in batches. Then, on the native side, the messages were received and deserialized and then processed. However, due to the asynchronous and batch nature of the bridge, communication wasn't always instant, leading to performance issues, especially in complex UIs or animations. To solve this problem, the team at Meta came up with JSI. JSI allows direct synchronous access to native functions without the need of a bridge. Amazing, right? Let's take a look at how it works. To understand JSI, you first need to understand these 2 things. First, JSI is a layer written in C++. Second, JSI uses shared memory, which is a memory space that is shared between JavaScript and native threads. More specifically, JavaScript and native code can both reference the same C++ objects in memory. Now keeping this in mind, JSI wraps the native function and modules and exposes them via storing a reference to it in the shared memory. Since the memory is shared, JavaScript can directly call the native method using the JSI API. Similarly, JavaScript does not need to pass any data through the bridge. The data is directly exposed in the C++ shared memory and can be accessed in the native thread via JSI. Therefore, we can conclude that JSI allows direct synchronous access to the native functions without the need of a bridge. Now, the JS and native communication via JSI should be clear. With that out of the way, let's move on to the next section, rendering. Fabric is React Native's new rendering system. Its goal is simple: make rendering faster, more consistent, and easier to sync with React. And to achieve this, Fabric can directly communicate to the native side thanks to JSI. Consider this simple React Native component. It is clear that this renders a simple text that says Hello World. Let's take a look at how it renders on the screen. In the first step, React recursively reduces this component to React host components until it cannot be reduced any further. In this example, my component is a React component and view and text are React host components. Now that they are reduced to their primitive forms, a React element tree is formed. This tree exists entirely on the JavaScript thread. Now, Another tree that is synonymous with the React element tree is formed called a shadow tree. Each node in the React element tree has a corresponding shadow node in the shadow tree with the same parent-child relationship. This process of creating these two trees is called the render phase. Once the shadow tree is created, the renderer enters into the commit phase. In this phase, layout calculations for each node in the shadow tree is carried out. This means properties like height, width, and position are calculated using the Yoga engine. These calculations are done mostly in the C++ layer on the shadow thread. Once all the calculations are done, the shadow tree is considered complete for rendering and is promoted into the mount phase. In this final phase, the shadow tree is converted into a host view tree. Each node in the shadow tree corresponds to a native node of the host platform. For example, on Android, a view is represented as a view group and a text is represented as a text view. Similarly, the host view tree is different for iOS. This tree is then used to render components on the screen. And this is how React Native renders stuff on the screen. What I just explained is a higher level view of what happens. If you want to know more about it, refer to the official documentation. Link is in the description. Okay, let's zoom out for a bit. We have now gone through each and every major part of the architecture of React Native except these two. Hi. Before we move on ahead, I just wanted to say that turbo modules and CodeGen are a huge topic in itself, and I think they deserve their own discussion. So what you're going to see next is how they contribute to the React Native architecture, but trust me, there is so much more to it. So if you want me to make a video on, let's say, creating your own turbo modules to run the native code, then you can let me know in the comment section below and show this video some love. Alright, back to the video. Turbo modules are a new system for defining native modules in React Native. Unlike the old native modules, turbo modules are lazily initialized, meaning they are only loaded when they are actually used, resulting in significant performance improvements. CodeGen is a tool that automatically generates C++ and native glue code so that your JavaScript can talk to native modules and views, without you having to write the boilerplate yourself. And with that, the new architecture of React Native is complete. Thank you for watching the video. I'll see you in the next one. Cheers.